Researchers make it harder for the bad guys. That's right now, in motion. The science of crime scene investigation has come a long way. DNA fingerprint science and a slew of other procedures tend to make it tough to perform the perfect crime. The ability to successfully retrieve and identify fingerprints has helped to place many perpetrators behind bars. But even though fingerprints are heavily relied upon as evidence, they do have their limits.
Well, many times fingerprints that are left on non-porous surfaces are not very distinct, and it is difficult for fingerprint examiners to decide who the fingerprints could belong to. So in such cases, what we can do is to develop the fingerprints further.
Fingerprint science, like some of what you see in crime dramas, relies on the chemistry of the print, the secretions that are on the finger, and more noticeably, on the ridges of the fingerprint. Common techniques such as dusting and fuming will usually bring up the print, but some surfaces don't allow for collection of fingerprints using these techniques because of the makeup of the surface. Akhlash Laktakia, along with Robert Shaler, have developed a conformal coating process that can reveal hard-to-develop fingerprints without altering the chemistry of the print.
So what we do is to take the material, take the sample, put it in a vacuum condition, and then shoot towards it a vapor of either the metal or the glass or whatever other material we have decided to use. And as this vapor condenses on top of the fingerprint, it starts to form a film.
It's somewhat like a pin art toy. You know, the toy with all the pins aligned on one end, tightly packed together. When you press on one side, you get an image of the original on the other. It's a rather simple analogy because Dr. Laktakia's procedure is much more sensitive and precise. But what should be understood is that scientists and crime scene investigators can obtain usable fingerprints from hard-to-develop surfaces, and all the while without destroying the original print and its chemistry.
They are able to reproduce the unevenness that is caused by the fingerprints very precisely on their top surfaces. And because they are made of a material that is not the same as the fingerprint material, therefore they are easier to see, they're easier to analyze. And if we take pictures of them, then we can also enhance them using software further.
Professor Laktakia and Shaler worked across disciplines to develop this process, and in working to make it smaller and accessible, they hope to have this technology in crime labs across the country and perhaps the world. For In Motion, I'm Kurt Parker.